It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to talk about limits of transcendental functions. Suppose we have here a limit of e to the power of 2x as your x approaches 0. So we are going to solve our limit here since we don't have actually any problem with exponential function here, except for when you got there an exponential in within a rational function. So later on I'll give you an example on that one, but for this one, since this is only a simpler exponential function, we don't have really a problem to that one. All we have to do is to simply just plug in the value of your x approach value to the x on the function. So here we have e to the power of 2 times, replace x by a 0, and 2 times 0 is a 0, so we have e to the power of 0, and any number raised to the power of 0 except for the 0 is 1. So why except for the 0? Because 0 raised to the power of 0, that's indeterminate, and any other number aside from the 0 there, once you raise that 1 to a 0, that's equal to 1. And e here is a constant value, so since that is still a number, once raised to 0, that's equal to 1. Next one, we have a limit of e to the power of 1 minus x as your x approaches to 0. All we have to do is to plug in. We have e to the power of 1 minus our x. Replace that with the approach value, which is 0. This is now equal to an e to the power of 1. And once you've got an exponent of 1, you don't need to write that 1. So we have an answer here, which is an e. Next, we have the limit of e to the power of 2x minus 2 as your x approaches 1. So again, we just simply plug in e to the power of 2 times your x here is 1 minus 2. This is equal to e to the power of 2 minus 2, which is equal to an e to the power of 0. This is equal to a 1. So let's have another one. We have the limit of the quantity 1 plus e to the power of x minus 2 raised to the power of 2 as your x approaches to a 2. We try to plug in the value, the approach value to your x. So we have 1 plus e to the power of 2 minus 2. And then we have to raise everything up to the power of 2. Simplify that one. We have that as 1 plus e to the power of 0 raised to the power of 2. This is equal to 1 plus e to the power of 0 is 1 raised to the power of 2, that is 2 raised to the power of 2, that is equal to a 4. We have limit of e to the power of 4x minus 2 times e to the power of 2x plus 1 as your x approaches 0. So again, we don't have a problem with this one, so all we have to do is to simply plug in our approach value to your x. We have e to the power of 4 times our x is 0 minus 2 times e to the power of 2 times 0 plus 1. Simplifying, we have e to the power of 0 minus 2 times e to the power of 0 plus 1. All the e to the power of 0, that's equivalent to a 1. 1 minus 2 times 1 plus 1, that will be equal to 1. 2 times 1 is 2, so we have a 1 minus 2 plus 1. 1 minus 2 is negative 1 plus 1, that will be a 0. We have here the limit of ln x as your x approaches to 10. So for natural logarithm problem, we don't have really a problem on that one. So all we have to do is to do the c substitution or replace your x here by the approach value. So we have here ln of 10, and that's it. You don't need to further go through with having the exact value on that one. You can have that as the final answer. For this last example, we have the limit of 2 over ln x as your x approaches 1 coming from the left side. If we are going to do the c substitution here, or just simply change our x with approach value, we have it as 2 over ln 1. But for ln 1, if you try to plug it in on your calculator, you will have a result which is an undefined in there, because we cannot look for the concept there of the natural logarithm or the logarithm. Is we are going to look for our exponent, in which that would lead to an answer, which is the argument here, which is 1. So once you say ln, our ln, or the natural logarithm here, is a log with the base e, and that's with an argument 1. This is equivalent to ln 1. Now, if you try to look at your e there, no matter what number you are going to raise that e with as an exponent, you will never be coming up with a 1 in there. So that is why this is undefined. Now, since this is undefined, our answer here could be either 2. Any of the 2 here. Positive infinity, negative infinity, because this is undefined. Now, since this is one-sided limit, we only have to choose among the 2. Negative or positive infinity. So how to do that one? We go over with the tabular approach. We are to look for numbers from the left of 1. So we cannot, by the way, we cannot have our value on x here as 0. That's a no-no. Because similar scenario with the ln of 1, which is undefined, ln of 0 is also undefined. So that is why we do not start with 0, although 0 is from the left of 1. We start with the next one, which is half of the 0 and 1, so which is the 0.5. And then solving for that one, we have here 2 over ln of 0.5. Inputting the entire thing on the calculator would lead you to an answer which is negative 2.885. And then we go to the next value of x, so which is 0.9, because we are trying to move closer to our 1 as the approach value. So we move closer, we have 0.9 on that one. And once you input this on your calculator, 2 over ln of 0.9, you will be getting an answer or a result which is negative 18.982. Then moving closer, we have 0.99 because we wanted to have our pattern as to what will be also the approach value of your f of x. So you've got here 2 over ln of 0.99. Input this one on the calculator and the result will be a negative 198.998. And then lastly, we may, although you can have more on this, we can add more 9 on this one so that we can really see the pattern. If the pattern on the values here is not enough for you, you can simply add more values there on your x. But upon inputting this one, the 2 over ln of 0.9999 on the calculator, that would lead to a negative 1,999. So if you try to look at the pattern here of the number is moving to the negative direction, but the number there becomes bigger but lesser in value, of course, because that's moving to a negative direction. So if you try to look at that, once your number becomes bigger and bigger and bigger, that's infinity. But since this is bigger to the negative direction, so that's becoming a negative infinity. So our answer, if we try to redo this one, our answer for this problem for the limit of your 2 over ln x as your x approaches 1 coming from the left side, that is a negative infinity. So that is how you are going to do the limit of the transcendental functions, focusing on the exponential function, and so with the logarithmic function. Part 2 of the video will be focusing on the trigonometric functions. So, once again, this is your teacher Jenny saying practice and practice, and that would lead you to perfection one day.